Good day, everyone. So, in today's class, we'll be looking at the topic friction. And at the end of the lesson, we'll be able to know what friction is, how surfaces resist motion, and then the calculation involved in friction. Let's dive into this. So, first, what is friction? Friction arises when two surfaces are in contact. That's very important. When two surfaces are not in contact, we cannot have what we call friction. So we say that friction occurs when two surfaces are in contact and then move or tend to move relative to each other. So being in contact is not enough for friction to occur. When they are in contact and they move relative to each other, then that's when friction will occur. And what is the role of the friction when two surfaces are in contact and they move? It tends to oppose the motion of their movement. So it plays a significant role in our daily life, affect how objects interact and move. Okay, so friction is a force that opposes motion between two surfaces in contact. That is what friction does. A force that opposes or tends to oppose the motion between two surfaces in contact. And there are two laws, major laws actually. There are other laws, but there are two major laws that guide friction. Okay? Number one, friction depends on the nature of the surfaces. Now, if the two surfaces, you could see these people here now, if the surface of their ends are smooth, it will be difficult for them to grip hands together like this. But if the nature of their ends are rough, then gripping will be much more easier. So the rougher the surfaces, the higher the friction. The smoother the surfaces, the lower the friction. So friction depends on the nature of the surface and also depend on the normal force. The normal force, of what we call normal at times, is a perpendicular force that acts vertically. Okay. So by formula, we say friction is equal to the product of normal force, that is this n, and the coefficient of friction. Okay, that is this mu. So the formula for friction is normal force and the coefficient of in the product of normal force and coefficient of friction, which is mu. All right. Now we have types of friction. We have the static friction and we have the dynamic friction. Sometimes we call it kinetic friction. In static friction, in this type of friction, the force, the frictional force tend to oppose motion between two bodies that are stationed. Okay, when two objects are together and they are not moving yet, then the friction that is keeping them in that position is called static friction. But on the other hand, two surfaces can be together and be moving. Okay, now the force that wants to stop them from moving continuously, okay, is called a dynamic friction. So it actually occurs between bodies that are already in motion. All right. Yes, even though the body is in motion, there is a force that is trying to stop that motion. That force is no longer static friction because static friction will not even allow the object to move at all. It will only make the object to be making an attempt. But in dynamic friction, the object will be moving, but there will still be an attempt to stop that movement. That attempt or that force that is attempting to stop that movement is called dynamic friction. So it occurs between bodies already in motion and oppose and slow down moving surfaces. Okay, those are the two major types of friction. Although we also have what we call the rolling friction when an object is rolling on the ground. That the force that is trying to oppose the rolling of the object is called um, rolling friction. But in our own curriculum, we focus on static friction and kinetic or the dynamic friction. Right? So, what are the advantages of friction? Since friction is seen to be opposers of motion, will it have an advantage? Yes. Yes. Now, number one advantage is traction. When we say traction now, it allows the gripping, it allows grip to occur when we are walking. Do you know that if there is no friction between the sole of your feet and the floor, as you walk on the ground, you will fall. But because there is roughness at the sole of your feet and the floor is not that smooth too, that is why the sole of your feet can grate the floor as you're walking. The same thing applies to driving. You see the tires, you see the vehicle you see on the road. If you check the tires very well, you see that the surface of tires are not smooth. So also the road surface are not also smooth. That is because if they are smooth, the friction will not allow the vehicle to be able to stop. It will keep moving. Okay, so it allows walking and driving to be easy, okay, without we slipping off. Then it also allows brake of vehicles to be effective. Do you know that there is no friction between the tires and the floor, like we said in traction part? When you match the brake of a vehicle, it will never grip because the floor and the tires are smooth. So nothing to stop, nothing to oppose it. Then friction also help in heat generation. Have you ever wondered when you rub your hands together and you keep rubbing, what do you experience? You experience heat. That is the effect of friction. Because of the opposition of motion between the two perms that you are rubbing together, okay, it leads to generation of heat. All right. And then this heat can be used as energy, to fuel a machine. Then we also use friction in manufacturing company. You see all the machines, all the gigantic machine that is being used in a manufacturing company, they make use of friction for them to be able to grind or even polish or drill. This drilling machine is made use of friction, grinding machine makes use of friction, polishing machine makes use of friction. If there is no friction when these machines are working, they will not succeed in achieving their aim. So friction, of course, has advantage, and whatever has advantage must have advantage too. So friction can lead to wearing and tearing. When two surfaces are rubbing each other often and often, and with time they'll be wearing off. It can lead to energy loss. We said in the advantage that it can lead to generation of heat. Heat is a form of energy, and when it is lost, it reduces the efficiency of the machine, which leads us to this one. When it is lost when energy is lost through it in a machine, the machine will not be effective like before, and it will also lead to noise. When machines are wearing off gradually, and the nuts are losing off, it will be making noise. And when there is generation of heat and there is excess generation of heat, it can also damage the machine. So these are the various disadvantages of friction. We have more of them. We just decided to look at this four. Now, how do you reduce friction knowing that it has advantage? In the case where its advantage, they need to reduce friction. One of the ways to reduce friction is by using either a roller or ball bearing. These are small materials. You can see all these small balls you see here, they are called ball bearing. Now, it does not allow these two surfaces to rub themselves. Instead of rubbing themselves, they are the one that is standing between them. So in this case now, the objects are not rubbing each other, which will prevent wearing and tearing. Another way to do that, to also reduce friction, is to apply lubricant, lubricating it. And lubricant are oil or grease. When you apply oil between these two surfaces, if you want to put in ball bearing, the oil will stand as a resistance so that they will not rub. It will be that the oil is the object between them. So it can replace the ball bearing with oil. Another way to reduce friction is to also streamline that object. When you streamline an object, you are doing it in a way that there will be reduction of air resistance. When there is reduction of air resistance, the object will be allowed to move. And the good example of this is our aeroplane. You see, aeroplanes are well streamlined in a way that when they are flying in the air will not be we have less force on them. So the air will not oppose the motion of the air for much because it is well streamlined. Then another way to to also prevent or reduce friction rather is by polishing. We said that the nature of the surface also is the affect the friction itself. So when the surface is smooth, then the friction will be reduced. So that's called polishing. When you are smoothing the surface of the object, then it will also reduce friction. So you do this reduction method when the disadvantage is playing out. Okay, now let us see one or two questions on friction. We've established that the formula for friction is the product of coefficient of friction and and um, um, normal reaction. So let us, for emphasis sake, let us quickly write that formula again before we look at this question. Okay, the formula is F, the frictional force. So frictional force F equals mu R, where the mu there is coefficient of friction and R there is normal reaction or normal force. So friction is measured in Newton because it's a force, and normal reaction is also measured in Newton. Why coefficient of friction is unitless? It has no unit. This has no unit. This has a unit of Newton. This also has a unit of Newton. Now, knowing that, let's look at this question. The frictional force between two bodies. The frictional force between two bodies A exists only when there is relative motion or tendency for motion. Okay, is that true? Yes. So frictional force exists only when there is relative motion or tendency for motion. We have said it before. When two objects are together, okay, are in contact with each other, then they tend to what? They tend to have friction between them. Okay, when they are in contact and then they tend to move, okay, relative to each other, then friction will occur. So that is true. The frictional force between two bodies acts so as to oppose the motion. That's also true. Okay, frictional force also opposes motion. Then say frictional force depend on the normal reaction between the two surfaces. That's true. That's the normal reaction here. The frictional force is relatively independent of the area in contact. Yes, that's true. We didn't say that before. That's one of the laws of friction. It does not depend on the area, whether the area is big or small. Frictional force does not depend on the area in contact, so it's independent. The last one has all of these characteristics. Yes, from A to D is correct, so the correct option is A. All of the characteristics are correct about friction. So question 2 says, which of the following does not cause a reduction of the surface tension of water? Now this one is what we'll get to know in our next topic. It's not for friction. All right. So let's go on to next question. Which of the following statement about friction is not correct? This time around, we have to tell the one that is not correct. Number one, the force, option A, the force of kinetic friction is less than the force of static friction. Yes, that is true. We said there are two types of friction, the static friction and the kinetic friction. Please note that the kinetic friction is always lesser than the static friction. Okay, and that's because static friction is the maximum force you must overcome before the object can begin to move. So when you have succeeded in overcoming that maximum force, then of course the next type of friction cannot be as high as the static friction. So in a nutshell, the kinetic friction is always lesser than the static friction, which is correct for this option A. The force of kinetic friction is less than the force of static friction. B, the force of kinetic friction between surfaces is independent of the area in contact, whether the normal reaction is unchanged. That's true. Friction is independent of the area. We have said it before. The force of rolling friction between two surfaces is less than the force of sliding friction. Okay, that is also true. Rolling friction is not as high as sliding friction. D, the angle of friction is the angle between the normal reaction and the angle of friction is the angle between the normal reaction and the force friction. Okay, the angle of friction. That's also okay. When we talk about angle of friction, we have another way friction can occur when you have an object like when you have an inclined plane like this, and an object is placed on it. Okay, so we have an angle here, angle between that inclined plane and the horizontal. Okay, now when we draw this, that's the way we go about it. Then we draw this. We call it friction in an inclined plane. So we have something like this, an horizontal line and a diagonal line. Okay, then this angle theta here. Now on the diagonal line, that's the inclined part. Now we have an object here, right? We have an object. Let's draw the object again. Go this way. That's the object. Now on this object, there is what we call normal reaction acting upward. Okay, so we have a normal force acting upward like this. As R, we use R to represent it. Now we also have the weight of the object always acting vertically downward. Okay, that is the W, right? Aha. Now we can also trace down this normal reaction downward, trace it down in a way that we now form a triangle with the weight, right angle triangle, such that this place is now angle 90. Now it has been proven that the angle here is same thing as the angle here. If I'm going to draw that out, this is what I've succeeded in drawing, something like this. Let me do that again. You have a vertical line like this, and then you have another one like this, then you have something like this. So we have angle 90 here, you have theta here. Okay. Now remember that this is W, the vertical part. Now this is R. Now there is a force here called frictional force that is preventing this object from falling. Okay, and that's what is here. Okay, so we have just again drawing a triangle. Now the question is saying that the angle of friction is the angle between the normal reaction, this normal reaction, now can you see it now, and the force friction. Can you see? Is that true? That's not true. The angle of friction is the angle between the normal reaction and the weight. That's not true. Can you see that now? It's not true. You see? That's how to check it. Now, option D is not true. Then friction may be reduced by lubrication. That's correct. So D is the correct answer because we have to check what is not correct there. All right? Okay, so let's go on to see the next question. Okay, here he said, a brick at rest on a horizontal table is pulled by a horizontal cord as shown in the diagram. Okay, this is it here. The force of friction on the brick A increases if the pull increases but the brick does not move. That's true. Now look at the brick here. This is a pull here. The cord is being used to pull the brick. Now option A is saying that option A here is saying that the force of friction on the brick increases if the pull increases but the brick does not move. That's true. When you keep pulling it with the cord and the brick refuses to move, that the force of friction is still increasing. All right, you have not attained the maximum force that can overcome it. So A is correct. B, the force of friction on the brick is directly horizontal to the right. The force of friction on the brick is directly horizontal to the right. This is the right hand side. If you see, that's also true. Okay, this is the force of friction directly horizontal to the right. This is horizontal to the right. Okay, not vertical. Of course, that is obvious. Then C, he said the force of friction on the brick decreases if an identical brick is placed on the first. Is that possible? If we place another brick on this first one, okay, it's saying that the force of friction will decrease. That's not true. The force of friction should still increase because the weight is increasing. So the force of friction should also increase, not decrease. So C is not correct. Then D said the force of friction, let's follow it again. The force of the friction on the brick is zero if the brick is pulled add enough to make it slide. Okay, yes, it's 0 because the friction has been overcome. All right, the friction has become, so at the point that it's moving, the force of friction has been amounted what to 0. Then option E said the force of friction, the force of friction on the brake change if the brake is turned on its side. Okay, that's true because the brake uh weight on its side is different from its weight when it's on the other side. So definitely the force that's acting on it will also change. Okay, it's like when you are standing and somebody is trying to push you, or and also now compared to when you are lying down. So the force will be changed because now the weight is now tending toward another direction. So that is correct. So the E is also correct. The one that is not correct is that the force of the friction decreases if an identical brake is placed on the first. No, the force of the friction should increase to increase. So C is the correct option. Yeah. So we are going to be ending the class here today. I hope you're able to learn something about friction as a force that opposes motion. Thank you for listening and have a wonderful day. Bye for now.